For this project, I'm going to talk about skyboxes, which are surrounding this scene. Like, we have a texture mapped to a very far wall right here on the right, and then we have another one on the left. And that makes it look a little more realistic, although I don't agree with these textures of having a horizon here, because the horizon line looks kind of weird when the textures end up meeting at a point like this line right here. Other than the horizon line, everything above looks kind of good, besides the clouds bending a little bit, but that's harder to notice. But if you surround your scene with the skybox, that's how most three-dimensional games work for displaying faraway objects. They don't actually render objects for hundreds of miles, because the computer wouldn't be able to handle that. And then for this project, we had a Bezier water patch, which is at the bottom here. I don't have the code right now because the teacher didn't want all the code when we turned it in, so I couldn't kind of restore all my files from half a year ago. But I do have this screenshot of the project. But okay, this water patch here is moving up and down and making wavy formations, and since the normals of the surface are changing as the water's making a wavy formation, it is reflecting light off of the faraway skybox. And it's giving a realistic water reflection look. And the way this works is we have these Bezier curves where you have point 0 connecting to point 3, but then you have these other points that act as pulling forces, which will pull the water up in this direction, and this point will pull it up in this direction. Then if you continued it farther and had 2 more points, you can make a wave, and you can move these points up and down to make the water keep moving. Anyways, that's it for skyboxes, and oh yeah, I should talk about tessellation as well, because that'll be in my next project as well. If we zoom in, instead of this being one rectangle, we turn the one rectangle into a lot of small rectangles. So light would reflect off of this point to the camera from a different point on the skybox, and then you get the 4 points and you're able to map that little subtexture inside of the mini surface here. And that's how that worked. If we used higher resolution, this would look better. It wouldn't look pixely. And let's move on to my final project. Let's see. I'm going to compile and run it right now. What I did is I made a randomly generated 3D terrain like this. I used something called the diamond square algorithm. It's a popular algorithm for doing this. And that diamond square algorithm would create a height map. Here it is. Here's one example. This one's more complex because it makes like a volcano and everything. But the idea is you make a rectangle of height positions that all flow well together and kind of create the terrain. The bright points here are the high points, and the dark points are the low points. And let's see. Instead of having one giant rectangle for the surface, I used tessellation, which made a lot of tiny triangles. You can kind of see it right here if you turn your resolution up. There's a lot of small triangles generating this whole surface. When I press the reset button, it'll randomly generate a new one. I could do that indefinitely, and I'll never get the same terrain, which is really nice for generating 3D worlds, because you can keep randomizing new ones until you see something you like, and then you can just tweak what you like. It's a lot more time efficient than building everything from scratch. And the reason the colors are changing is because I'm using 2 different shaders. One is a normal shader, which uses the Phong reflectance model, which I'll talk about in a few minutes. The other is toon shading, which limits the amount of colors that can be seen, which makes the scene look more cartoony. Another name for that is cell shading. A lot of games use it to make their game look like a cartoon. And let's see, if I move around, you can see the light actually reflects and changes based on where the camera is. This is how it would work in reality. Maybe not that dark, but it would work this way. And I'll explain that in a second. In order to get that reflectance model, I used the Phong reflectance model, which is described here on Wikipedia. I'll put a link in this under my video on my website. It basically takes three components: the ambient lighting, which is the amount of lighting around the object; the diffuse lighting, which is assuming the object does not have any glossiness to it. It'll give you what the reflectance would look like off of that. And then the specular lighting, which is the glossiness. You combine all three of these together and you get a nice looking three-dimensional object like this. And I had to write the project with GLSL shaders, which is how it's just about always done in OpenGL. Here's a vertex shader, and here's a fragment shader. These are examples of the Phong reflectance model. You load these into your program and they run along with it. It's not your CPU. That makes it so that your graphics card can do all the computations of the lighting and the shading, and leaves your processor open to do the more complex thing that the processor has to do, like all the algorithms and such. And that makes the program look better and run faster. Otherwise, I probably wouldn't be able to run this thing in 60 frames per second like I can now with light reflecting off all these tiny surfaces. And yeah, let's see if there's anything else. Oh yeah, Blender. If I press C, I'll move to the airplane that I have flying through the portal, which is making the different shader load. And it's being sucked in kind of like a black hole indefinitely. And the way I did this is I loaded a model from the internet, completely free, open source models you can find all over the internet. I'll put a link to where I found this jet under my video. And yeah, you can pretty much load it in Blender, edit it, do whatever you want with it. And then if you have save it as a file, and then you have to program the parser that will parse that file and load it as data into your program. And that's what I had to do for this final project. And this final project was all optional. We had a lot of choices to choose from. I chose the procedurally generated terrain, and I added the jet and the portal in as kind of optional things to do afterwards when I was done. And I have a third shader for the jet as well. It paints it kind of grayish instead of being uncolored like the one that comes from the model file. And I had to triangulate the model to where like rectangles turn into two triangles, because that makes it a lot easier to load into the program, because then I'm only dealing with triangles instead of dealing with rectangles and all sorts of other kind of shapes. And this Blender program is a free open source program for doing model editing, and it had a triangulation option built into it, so that made it really easy. It's free and open source, and it's very professional. This is actually used in the field of computer graphics. And let's see, I think that's it for my final project. Alright, thanks for watching.